Kia ora koutou. In today's video lesson, we are going to be going over a normal distribution problem involving machines that make corks. Okay, first off here, Leo works for a winery. He's responsible for 2 cork machines. First one produces corks with diameters that are normally distributed. The mean of 3.01 centimeters and a standard deviation of 0.07. Use this model. Acceptable bottling corks have a diameter between 2.9 and 3.1 centimeters. What is the probability a randomly selected cork is acceptable? So first thing we always do, we write down our mean, our standard deviation, and the x values. We're going to then change each of these x values to a z value. When I look up the 1.571 in the table, I get a probability of 0.4419, and when I change the 3.1 into a z value, I got 1.286. Looking that up in the table, 0.4008. Now, since my shading is between 2.9 and 3.1, I'm adding those two together, giving me a probability of 0.8427. Next one is on machine 2, where they specifically say that the mean and the standard deviation are different, but the same question. Which of these 2 machines, 1 or 2, is more likely to produce corks that are acceptable? And from the last question, we know an acceptable cork is between 2.90 and 3.10. But since the mean and the standard deviation have changed, that's going to change our z values. So a 2.9 x value has a z of negative 3.75. I look up 3.75 in the table, and I got 0.4999. With this next one, an x of 3.10 has a z of 1.25. Looking up 1.25 in our table, I have 0.3944. Adding those together, I got 0.8943, which is larger or a higher probability than the 0.8493. So the second machine is more likely to produce acceptable corks. Next one. This one now is an inverse normal pati. And what I mean by that is we're told the probability that 25% of the largest diameter corks are produced by machine 2 can be used in either bottling or remachined for use elsewhere. So since we know that probability, that is known as an inverse problem. So we don't know what this x value is. All we know is that the top 25% are in that range. So when we look up 0.25 in the table, so now with this one, we're not using a z to find a probability. We're going in the opposite direction. We're using that probability to find the z value. So if the probability is 0.25, we look that up in here to find the z value. Well, that gives us a z of 0.674 when the probability is 0.25. Putting that into our equation, solving for x, we get x being 3.077, so the minimum diameter 3.077. If the algebra is something you need some revision on, please let me know. Lastly, we want to find the probability that the first cork from both machines has a diameter greater than 3.07. So starting with machine 2, that should say machine 1. So we want to find the probability that x is greater than 3.07. First step is always draw your curve and shade appropriately. So the mean for machine 2 is 3.05. We have the standard deviation 0.04 and x 3.07. Now the question asks the probability that x is greater than 3.07, so I've shaded here. I change my 3.07 to a z, I get 0.5. I look up 0.5 in the table, and I wrote in my probability of 0.1915. But that's not where I've shaded. So that 0.1915 will be subtracted from 0.5, giving a probability of 0.3085. I do the same thing. This is machine 1. This is machine 1, doing the same thing. Change my x value to a z. I get 0.857. I look up 0.857 in the table. Now, since the table shading the probability always starts at the mean, so that's this probability, 0.3042. Since I want the shading to the right of that, I subtract that blue number from 0.5 and I get 0.1915. Since we now want the probability that this happens and this happens, in other words, the probability both machines have a diameter greater than 3.07, I multiply those two together, getting 0.0604 for our excellence. Okay? Any patai, send them my way. Thanks for watching. Mauri mahi. Mauri ora. And if you liked what you saw, please consider giving it a like. Kakite ano.